Hi and welcome. In this video, I'll show you how I created a clone of the game Pong using Godot Engine. I started by downloading the game engine from the official website. To do that, visit godotengine.org and click on the Download Latest button. At the moment of recording this video, the current version was 4.0. I downloaded the version for Linux, but the application is also available for Android, Windows and macOS. Now there's even a version that runs directly in the browser. Each one has two flavors, a standard version and a .NET version, which supports C#. I have downloaded the standard one as I'm a beginner and will be using JavaScript rather than C#. The very first time you launch the application, it will show you this message. That is because there are no projects yet. Click on Cancel to close the window. Then, from the Local Projects tab, click on New Project. Browse to the location where you want to store the project and create the folder structure if it doesn't exist. Back to the previous screen, enter the name for the project. I'm going to call it Pong. Then click on Create Folder. When a new project is created, Godot creates a new folder and then adds some files to it. These will hold project and environment settings. There's also a PNG file with the famous Godot logo. For our purpose, I am going to add some folders and files to this structure. These are for the resources that the game will use. I will create 3 folders, one for the images, one for the text font, and one for the code. Then I copy the images I have prepared previously into the respective folder. One is going to be the background of the game. The other images are for the pads and for the ball. I have also downloaded a font with a retro vibe, which I think would suit the game very well. I'll put the details in the video description. You can see on the file system area on the bottom left that the file and folder structure has updated and now shows the new items I have added. Now I'm going to change some project settings. On the menu, click on Project and then on Project Settings. In the General tab, go to the Display section and select Window. I'll change the size of the window to 1920 by 1080. After that, scroll down to the bottom. Change the stretch mode and select Viewport, then select Keep as the aspect. Then click Close. Now we are ready to start building the game. First, we are going to create a root node. As it is a 2D game, we will use a 2D scene. To add the background, right-click on the main scene and select Add Child Node. From all the search results, select the one just called Sprite 2D and click on Create. Select the sprite object and on the right column, look for the field Texture and click where it says Empty. Click on Load and browse to the image folder. Open the background.png file. To have the image in the right place, click on Transform on the right column. Then change the position X value to 960 and the position Y value to 540. These correspond to the middle of our game window. We can now rename our scene as Main. Then save it with the same name. Now it is time to add the walls to the game. These will be used to contain the ball within the play area. Select the main scene and right-click on it. Click on Add Child Node. On the search box, type 2D. You'll see the search results change dynamically as you type. From the results, select Static Body 2D and click Create. The new object will appear on our scene list, but it has a yellow warning. This is because it needs to have a collision shape associated, so it could interact with other objects, like the ball. To resolve this, right-click on our static body and select Add Child Node. Start typing Collision and select Collision Shape 2D. Then click Create. On the right column, click on Empty next to the Shape field. Select the new Rectangle Shape 2D. A small rectangle will appear at 00. To change the size, select Extent and set the X value to 960 and the Y value to 10. The position is still in the wrong place, so click on Transform and set the position X value to 960 and the position Y value to 10. Now select the static body 2D object, right-click on it and rename it to top wall. Right-click on it and click Duplicate. Rename the new object as bottom wall. Select its collision shape and click on Transform. Then change the position Y value to 1070. This will move it to the bottom of the game area. Now is the time to add the pad. For that, click on Other Node and add a new static body 2D. Right-click on it and rename as Pad. Select the pad, right-click on it, and click a child node. Select Sprite 2D from the list. On the right column, click on Empty, next to the texture field. Select Load, and open the image called pad.png. Leave it on the default position of 0, 0. Now add a collision shape to the pad. Right-click on the pad scene, be careful not to do it on the sprite. Select a child node and select Collision Shape 2D. On the right column, click on Empty on the Shape field, then choose New Rectangle Shape 2D. Click on it and change the size to 40 by 200. We can now save the scene with the name pad. We're going to repeat the steps to add a scene for the ball. Click on the plus sign and add a new static body 2D. Select the ball scene, right-click on it and click a child node. Select Sprite 2D from the list. On the right column, click on Empty. Select Load and open the image called ball.png. Now add a collision shape to the pad. Right-click on the ball scene. Select a child node and select Collision Shape 2D. On the right column, click on Empty on the Shape field, then choose New Circle Shape 2D. Click on it and change the radius value to 20. Now the collision shape should have the same size as our sprite. We can now save the scene with the name ball. Rename the new scene created as ball. Go back to the main scene. Right-click on it and select Instantiate Child Scene. Then load the pad scene we created earlier. Rename it as Player 1. Right-click on it and create a duplicate. The new object is automatically named Player 2. Now right-click on the main scene and click on Attach Script. Leave the default options and save the file into the source folder as main.gd. Now we are going to create a new function called Start Game, so it is called when the game is launched, or whenever we want to play a new game. We will add some lines of code to define when the two players will be positioned to start a new game. I'll put them 100 pixels from the sides and halfway vertically on the screen. If we play the current scene, we see that the two pads are now positioned. We're going to use code to add an instance of the ball. That way, we could remove the ball when a player wins, and create a new instance if we want to play a new game. We'll use a function called preload to load the ball scene. I'm making a mistake when trying to create the instance of the ball. Although this worked initially, I had a weird behavior if I wanted to start a new game. I'll change it at the end of the video, and the code I'll put on GitHub will have the correct code. For now, we can configure the starting position of the ball. It will be starting its movement from the center of our play area. Now go to the ball scene. Right-click on it and select Attach Script. Leave the default options and save the file as ball.gd. We're going to create two variables to define the speed and velocity of the object. In the ready function, we will add the initial velocity of the ball in each one of its components, x and y. Now replace the process function with a physics process one. This function will control the movement of the ball. The function is called by the game as many times per second as the refresh rate of your display. So on a 60Hz monitor, it would be called 60 times per second. We start by adding a line to update the velocity of the ball proportionally to the variable speed that we created earlier. Add the function move and collide to update the position and velocity of the object. If we play the game now, we can see that the ball is moving, but stops when it reaches the bottom wall. Now we are going to add the code to detect if the ball is colliding with another object. If there is a collision, the velocity of the ball must change, so it bounces off the walls and the pads. Now go to the pad scene. Click on File, New Script. Leave the language as GD script. Change the inherits value to static body 2D. Save the file as pad.gd in the source folder. As with the script for the ball, we are going to create two variables to define the speed and velocity of the object. With the process function, we will check if the user has pressed the control keys and change the velocity of the pad accordingly. For player 1, we will use up and down keys. We will modify the script for player 2 later, so we use the A and Z keys to control its movement. As with the ball, we will also include a physics process function to take care of the movement of the pads. Copy the code of the script and create a new file for the second player. Then paste the code and save the file. Go back to the main scene. Right-click on the player 1 and attach the script pad1.gd to it. Now, after correcting my mistake, if we test the game, the player 1 moves when we press the up and down keys. Repeat the process of attaching the script pad 2 to the second player. As you can see, both players are moving at the same time. We need to change the script pad to use different control keys. First, click on Project Options. Select the Input tab. Here you can define the controls to be used by the game. There are a few created by default, like the up and down controls. These can be assigned to keys, mouse movement, game controllers, etc. We are going to add 2 new controls, UIP2 up and UIP2 down. For that, enter the name of the new control, then click on Add. Repeat for the other control. Then click on the plus sign for each one and press the key you want to assign. I'm using the A and Z keys. Now get back to the script for player 2 and change the name of the controls to the new ones. When you test the game now, the 2 players move independently. Now get back to the main scene. Right-click on it and select a new child node. From the list, select Label. Select the new object, and on the right column, scroll down to Theme Overrides. Expand Fonts, and click on Empty. Then click on Load, browse to the Fonts folder and load the font file we copied there. Change the font size to 128 pixels. To position the object, click on Layout, then expand Transform, and enter the coordinates for the new label. This is going to be used to keep the score of the first player. Change the alignment of the text so it is centered. Create a duplicate of the label. Now go to Layout, Transform, and change the coordinates. Get back to the main script. We will add 2 new variables to manage the scores of the 2 players and initialize those to 0. On the script for the ball, we are going to add a signal. This will be sent each time one of the players scores a goal. We will detect that by monitoring the position of the ball. If it leaves the game area, the event will trigger the signal. Now we need to connect the main script to the signal, so we could do things like increasing the score of a player. This will be done by a new function called goal, which will receive as a parameter the number of the player thus scored the goal. As you will see later, I am making a mistake here. There should not be an else statement, but an else if. I will correct that later, as otherwise the score grows indefinitely after there is a goal, as the condition would match all the time. I think the syntax for the connect function may have changed from previous versions of Godot Engine. After a bit of try and error, I managed to find the right syntax. The process function will update the score of the players. We do this by changing the text of the labels. Now I need to correct the part of the code that checks if there has been a goal. It finally works, but the speed is very slow, so we'll increase it a bit both for the ball and the two players. Back to the main script, we are going to check if any of the scores is bigger than 3. In that case, we will end the game. Create a function called GameOver, and for now, add just a pass statement, so it does nothing. The function should receive the number of the player who reached 3 goals, so we can declare the winner of the game. To show the message, we need another label. The text on the label will tell the game is over and show the winner. Then it will ask if we want to start a new game. If yes, it would call the start game function. If not, it will close the game. We will assign the same font as before, but in this case, the size will be 64 pixels. Center the text both vertically and horizontally. From Layout Transform, change the coordinate so it appears centered on the play area. When we are happy with the position of the label, we can go to Theme Overrides, then expand Color, and change the font color to anything we like. We can also add a border to the font, using a different color. When we run the test, the show appears on the screen, but we only want it at the end, so we need to hide the label from the start game function, and show it only from the game over function. Now the call code destroy the ball object when there is a winner, so the ball doesn't keep reappearing on screen. We want the text to be dynamic, so we could change in real time the player who won. So in Game Over, we will add a line to define the text to show. The player will be inserted via variable. We will now add a new function to process the user input and know if we should start a new game or leave the game. This will read the keyboard input and will take one action or another depending on which option selected the user. For that we need to create two new controls and assign them to the letters Y and N. Here's where I had the weird behavior that I mentioned earlier. For some reason, when pressing the Y key, the game also ended. As I mentioned, this was due to how the ball object was instantiated. So here's the right way to do it. First, remove the instantiate method from the line where we preload the ball scene. Then create a new variable called the ball. In the start game function, assign the ball to a new instance of the scene. Then replace each call to the previous object with a new one. Now we have a working game in less than 1 hour. I have uploaded all the code and resources to GitHub, so you could download it and use it as a base for your own versions. You can find a link in the description. I hope you enjoyed this video, and we'll see you soon with another game. Thanks for watching. Bye.